Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. For a compound to be aromatic, it must satisfy Huckel's rule. 1. It must be cyclic. 2. It must be planar. 3. It must be fully conjugated. Every atom in the ring must have a p orbital participating in the pi system. And 4. It must contain 4n plus 2 pi electrons where n is a non-negative integer. Moving on to the next step. It is a 6-membered planar ring with nitrogen, fully conjugated, and has 6 pi electrons. N is equal to 1, 4, 1, plus 2 is equal to 6. It is aromatic. Moving on to the next step. It is a 5-membered planar ring with NH. The nitrogen lone pair participates in the pi system giving 6 pi electrons total. N is equal to 1. It is aromatic. And for the final step. Two fused benzene rings, planar, fully conjugated, 10 pi electrons, N is equal to 2, 4, 2 plus 2 is equal to 10. It is aromatic. Evaluate option B, norbornadiene bicyclo, 2.2.1, hepta, 2,5, diene. This is a bicyclic compound with a CH2 bridge that forces the molecule into a non-planar geometry. The two double bonds present are not part of a continuous cyclic conjugated pi system because the sp3 bridgehead carbons and the CH2 bridge prevent planarity and full cyclic conjugation. Since it is not planar and not fully conjugated in a cyclic manner, it does not satisfy the criteria for aromaticity. It behaves as a non-aromatic, olefinic compound. Norbornadiene, option B, fails the planarity and cyclic conjugation requirements for aromaticity, so it would not be considered aromatic in its behavior. Therefore, the correct answer is B. Therefore, the correct answer is option B.